Okay, so I'm sharing my screen now. So now let's go to our notes. And if you can be able to see my screen, I think the farthest we had gone was this vector. Oh no, we had done vector semantics already. And we had said that there's some interesting examples that you can find there. And I had requested you to look at some of the work, some of the topics, applications of that as well. Like, for example, there's this topic analysis. And this should also be this. Okay, this is the beginner's guide, but there's also this pre-processing for text processing. So I think you should. These are self-explanatory documents, and you should be able to follow through them. So if I open this one quickly, we're not going to take too much time there. But this was on topic analysis, and this is one of the practical things that you could have. We can try. So after reading all this, which I think we went through last time, what's topic analysis, scope of topic analysis, how does topic analysis work, and all that stuff. Topic analysis, use cases and applications. So we could go there. Remember, topic analysis whereby you are taking text and you are trying to extract the topics that are being discussed there. So the topics could be identified through key phrases or what you call the named entity extraction. So named entities are like the nouns that you find in that document. All right. And we say that it can be applied at all these levels, the document, the sentence, and the substance sentence. And this thing is scrolling slowly here. So I hope you read all this. And going down, this one is even talking about deep learning and all that stuff. Yeah, so there are some interesting examples given here, like brand monitoring. Let me show you. They start somewhere here. Yeah, this one's here. How to use topic analysis for your business. So social media monitoring. At least by the end of this unit, you should be able to know how to do this social media monitoring. That is maybe by looking at phrases that indicate some certain directions. Like I told you to look for the hate speech papers. I hope you did. You can just Google quickly here. For example, one of them, so that I can show you practically. If you just Google here, let's say hate speech model Mushemi. So you can look for such a paper. Maybe somebody called Ombui. Ombui was the co-author. Yeah, there's something here at the University of Nairobi Digital Repository, so you can read that. There's something at the ResearchGate, you can also read that. There's a PDF one here, like this one here. Let me just open this one, for example. This is from the ResearchGate. And just the abstract alone. This paper is called, where is the title of that paper? Yeah, the title is here. Psychosocial features for identifying hate speech in social media. So if you look at the abstract, it says that this study uses natural language processing to identify hate speech in social media, code switched text. Now, when you find this word code switched, it means that people are using, let's say, two languages, like Swahili and English at the same time. So you want to see how we can identify hate speech in social media, where two languages have been used. Swahili, mostly in Kenya, people use Swahili and English. Sometimes they also combine it with mother tongue, but I think we only looked at Swahili-English combination. So then they go and explain how this paper is, that it trains 9 models and tests their predictiveness in recognizing hate speech in 50,000 human annotated data sets. The article proposes a new hierarchical approach that leverages latent dirichlet analysis. So you can see we are using the LDA, latent dirichlet analysis. We saw this when we are looking at methods of when we are looking at SVD, for those who maybe missed the class. When we are looking at SVD and those kind of topics, we saw that the LDA is one of the methods that have applied that SVD thing. So we used latent dirichlet analysis to develop topic models that assist building a high-level psychosocial feature set that we call PDC. So PDC was organizing words into word families. So we were organizing words into word families, which helps capture code switching during preprocessing for supervised learning models. It was informed by the duplex theory of hate. The PDC feature are based on a hate speech annotation framework. So it goes on to explain how it did it. So frequency-based models employing PDC feature on tweets from 2012 to 2017, Kenyan presidential elections yielded an F-score of 83%. And of course, the other metrics were precision was 81, recall was 85 in recognizing hate speech. So the study is notable because it publicly exposes a rich code switched data set for comparative studies. Secondly, it describes how to create a new PDC feature set to detect subtitle or subtle types of hate speech hidden in code switch data that previous approaches could not detect. So you can see here, we were detecting subtle types. What subtle means, you cannot just easily see them, and they're actually hate speech, but you could notice them from this model. So this is an example of practical things we've done with the students, but this was I think PhD student, so you should not get worried about that. All right, so let's go back to that. I think we were on which one now? I forgot. Yeah, this one here. So that was on social media, but in this document, you'll see they have also done it. So there's brand monitoring, customer service, voice of customer, and business intelligence. So please make sure you read this. Exams usually come from such things, I can tell you from now. I can tell you, for example, you use something, a certain algorithm to show how you can do brand monitoring or business intelligence. Maybe business intelligence too general here, because we were dealing with the OLAP and all those things. But things like voice of customer, I should have read them. So they explain down here. So don't say you're not taught. They're here. So they're saying you could use topic detection to analyze what users are saying. And then if you come down, you can follow reactions to marketing campaigns or product releases in real time and get an accurate map. So the example here is Trump versus Hillary. Remember, there's a presidential campaign sometimes in the US. And they have used Monkeyland to do that. Monkeyland is one of the ones that we have been advocating for using this. And it could analyze millions of tweets posted by users. And these were some of the results. These are the candidate sentiments. The red is a Trump, and the Clinton is the blue one. So you could see some of the sentiments. Most of them are bordering negative. So you can see on the axis here, sentiment. It could be positive up here, and sometimes it could also be negative. So you can see most of the time Hillary never got positive. She only got negatives. Then there's brand monitoring. They've explained how to do it. And here there's an example. They have shown this customer service and all that. So please make sure you read that. That's what we did last week. Now, for this week, what I want us to do is not very different from that, but let's look at what's remaining. So if you go to 6B, that's within our folder, you have these words to vec. Words to vec. Remember this word to vec? We also learned it last week or the last week, but one, where we are talking of skipgram and SIBO. And I told you don't have to get worried about the deep algorithms. Just know that they are basically neural network based. And you give them either context words to predict a word, or you give them a word to predict the context. So if you open this, maybe it's updated. It's what do you call it? It's passed by time. So what I've done is that I've looked for where they have kept now this, and it's actually in where is that? Yeah, it's here actually. Whatever you can see here. So this is an example of a TensorFlow. You can actually look for this in this is in TensorFlow, by the way. And as for those of you who know it, TensorFlow is one of the most commonly used frameworks. And therefore, if you can render your word to vec, which means either you are rendering the skipgram or the SIBO onto the TensorFlow, then you just need to call a code, a library, and it works. So here it says, and by the way, you can even download the notebook. Or you can even run it directly from a Google Colab. Or you can even view the code under the GitHub. So you have all those options. But here it says that what to vec. Let me give you this so that we can read together with you. So I'm posting it on your chat. So where is that? It's here. So I'm putting it on your chat. Click on the link I've just sent. If you click on that link, it will take you to where I am. And you can save that link for later use, because links usually disappear after we go. Now, so it says here that what to vec is not a single algorithm. So it's not a single algorithm. Rather, it's a family of model architectures and optimizations that can be used to learn from word embeddings from large data sets. So embeddings learned through what to vec have proven to be successful on a variety of downstream natural language processing tasks. Here they have given two papers here. So these papers, propose two methods for learning representation of words. So this one we saw last week, the SIBO and the skipgram. So they are basically written as two separate papers, and you can read more about them. But for example, the SIBO we saw last week, it was predicting the middle word based on the surrounding context. So you are given the context. We saw this. You are given the context, then you predict the middle word, and the context would consist of a few words before and after the current middle word. So the architecture is called a bag of words model, as the order of the words in the context is not important. So the order of the words is not important. So if we say, I eat ugali with sukuma wiki. So the context of the word ugali, it depends on the window. So I eat ugali with sukuma wiki. So if you have a window of two words on the left and two words on the right, so the context of the word ugali would be I eat. So then it skips ugali. Then it goes to with sukuma wiki. That is if you have taken care of the order of the words. But usually you can you can see that it is very limiting. So what they do is that they take a whole sentence or a whole phrase, as we saw earlier, either a sentence, a phrase, or a paragraph. But mostly is a phrase and a sentence. So they take a whole sentence, and then they make like they remove all the plumbing words, as we call them, the commonly used words, like with, it, she, and they remove all those. Then they're left with the keywords, and then those keywords now they can combine any two. If the window was 5, so it could be any 2 on the left and any 2 on the right. The window can be bigger. It can even be 9 or 10 or whatever number you want. But remember, the idea is that with those context words, we want to predict the middle word. Then the skipgram is doing the opposite. So it predicts words within a certain range before and after the current word in a sentence. And I think they have some worked examples here. Skipgram and negative sampling. So they have taken you through this. Again, this is something that you should try practically because you can download this code, as you can see. They have explained the window size. So if the window is 2, you can see a wide there. So this one here, then the wide. There's also wide and road. There's also wide and shimmered, and so on. So they have explained that concept. It's 2 and 3. Then they have given some mathematical treatment. This is simply the training objective. If you are training, what are you maximizing? So the training objective, what you're trying to maximize in the skipgram model is to maximize the probability of predicting context words given the target words. Yeah. So for example, or for a sequence of word W1, W2, WT, the objective can be written as the average log probability. So they've done the average log probability here. So 1 over T, the summation from T is equal to 1 to T. Where T you can see is the total number of words, to T. And then here you are varying the window. So J is you are varying the window. So it could be minus C to C. So you're varying that context. But J can never be 0. Because if it is 0, it means you have no context on the left. And so on. So they have given the mathematical treatment there. And then here, they have tried to show what the thing is coming up. Now, more importantly, they are showing you how you can do that kind of an example. How you do the setup, what to import from on the TensorFlow, and so on. So it's an easy example.
Hashim, did you tell the doctor that I'm a drop off? Ama ni kwangu peke yangu?
It's everyone.
Yeah.
Yeah, please inform him asikuwa anajiongelesha because he was
Guys, mnanisikia right?
yes.
Yeah.
The like amesema power imeenda on his end, so he cannot join the class. Amesema we